Hi students, today we're going to talk about properties of logarithms. After we watch the video, you can refer to your folder for your homework. There are basic properties of logarithms we've visited with before. For instance, if you have a base and this number is your exponent and this number is your answer, to write that in log form, we write log base b of your answer equals your exponent. So if you took it out of log form, you start at the base to the exponent and equals the answer. So it would be base to the power of e is equal to a. Well, we're going to apply that down here. There are some rules down here that we can use. For instance, log base b of 1 equals 0. In other words, no matter what b is, if this number is a 1, the answer is always going to be 0. Let's see why that works. 3 to the 0 power is equal to 1. True. 3 to the 0 power equals 1. No matter what this base number is, any number to the 0 power equals 1. When these two numbers are the same, the answer is always 1. Here's an example. 9 to the first power is equal to 9. True. Here's another example. If these two numbers are the same and you have a power, then your answer is that power. Well, it's going to make sense when we see an example. 7 to the x power equals 7 to the x power. And this one I fondly refer to as the Nike rule. Just do it. When your base and the base of your logarithm are the same base, the answer is always this last number right here. That is the answer. So here's an example. 21 to the log base 21 of 432 equals 432. So if we applied those rules down here, here's one right here, 10 to the log base 10 of 432 equals 432. Here's one with a natural log base e of 432 equals 432. So just moving through those same rules. The common log is base 10 when there is no number. Down here, we know the base is understood base 10. And these are the same four rules that we just went over. 10 to the 0 power equals 1. 10 to the first power equals 10. 10 to the x power equals 10 to the x power. And our Nike rule again, just do it. There's no work to it. It's the answer. That last number is always the answer. Here it is, same four properties, only using natural log. The natural log is base e. When ln is used, there is no number in the base. It's an understood e. And we know e represents the number 2.71. So we have small e's down here. They're understood that they're there. So we have e to the 0 power is equal to 1. E to the first power is equal to e. E to the x power is equal to e to the x. And once again, the Nike rule. Just do it. There's no work to it. Back here, these problems are slightly different. It says evaluate each logarithm. Evaluate means find what it equals. We want to know, what does each one of these equal? Well, let's see if we can evaluate these in our head. This would say 3 to the x power is equal to 81. 3 to the x power equals 81. You could take a calculator and you could play with it. It's not 3 to the third because that's 27. It's actually 3 to the fourth power. So, or you could get like bases, like we did yesterday. 81 is 3 to the fourth, so x equals 4. Okay, take this out of log form and write it in exponent form, and it would say 5 to the x power equals the square root of 5. Or 5 to the x power equals 5 to the 1/2 power, 1/2. Your exponent divided by your root. Using the 1-to-1 property, x equals 1/2, and we've solved it. Here's one more. We have 1/3 to the x power is equal to 9. We're just taking these out of radical form. Let's try to get like bases. 1/3 is the same as 3 to the -1 power, and 9 is 3 squared. A power to a power, we're going to multiply, so we have 3 to the -x power equals 3 to the 2nd power. So -x is equal to 2, and x would equal -2. And there we have it. Using the 1-to-1 property, we set our powers equal. Last one, 5 to the x power equals 1/25. 5 to the x power equals 1/125. So let's try to get like bases. 125 is 5 cubed. 1/5 cubed is the same as 5 to the -3. Using our 1-to-1 power, x is equal to -3. Okay, well, those were okay. We were able to do those in our head. But what if we were not able to do it in our head? What if we had something like this? Log base 21 of 57 equals. That says 21 to some power is equal to 57. 21 to some power is equal to 57. Well, I don't even know that. I can't do that in my head. I know 21 to the first power is 21, and I know 21 to the second power, well, I know 20 times 20 is 400, so that's got to be over 400. So we've jumped way past 57. Well, this is where our calculator comes in handy. We have that log base key in Desmos. We could use that. Or back in the day before we had calculators that our teachers would let us use in class, we had a formula called the change of base formula. And the change of base formula said you can use base 10 if you take the log of x and you divide it by the log of b. The log of x divided by the log of b. So what you're doing is you're changing the base to base 10. So I did that in my calculator. I took the log of 57 divided by the log of 21, and I got 1.33. So over here, if I took 21 to the 1.33 power, and that's rounded off, so it's not going to be exact, I would get 57. Okay, that's it for part 1. I'm going to do a second video for part 2. So tune in. Bye.